Here's a little circuit I designed for fan control, using a thermistor to sense heat and turn on and off a fan. Here is the schematic. Uses an LM311 here, comparator, little thermistor, adjustment for the temperature, drives a transistor that runs the fan. Pretty straightforward. Here's the little thermistor. Okay, here we're set up with power on the circuit, the fan, the thermistor. I've readjusted the pot to kind of work in this test. And I'm going to use my soldering iron instead of the heatsink. Now normally what I would do is use some silicon caulk or that sort of thing, just kind of to glue that thermistor down to the heatsink so that it would sense the actual heatsink temperature. I'm going to move my soldering iron kind of close to the thermistor. It's about a ½ inch away. And as you can see, just that amount of heat, the way I've got it set up, has started the fan. Now it's kind of interesting using a comparator like this, because the curve coming up with one input comparing another input from this voltage that's going through the thermistor, right at the point of turning the fan on, the circuit would typically want to try to oscillate kind of back and forth, back and forth. The fan just went off there, by the way, because it's cool enough. Anyway, to get back to my point, the circuit would tend to oscillate back and forth and back and forth. They do that right at that ragged edge. So to avoid that situation, we use a method called hysteresis, which when the comparator says, it's about ready to trigger, and in fact does trigger for the first time, a little bit of the voltage from the output is fed back into the input to shift the comparator voltage just a little bit up higher so that it says, aha, I see, we want to be on now. And it will run until the thermistor gets the circuit cool enough again. Let's do that real quick again. And there we started.